There is a planet out there worth more than every economy on Earth combined, more than every gold reserve, every stock market, every piece of real estate on every continent. A world where the surface is not rock or gas or ice, but diamond. Solid, crystallized carbon, compressed under pressures so extreme that the entire planet has become a gemstone. And this is not science fiction. This is a confirmed discovery, orbiting a star you can see with the naked eye on a clear night. The planet is called 55 Cancri e. It orbits a sun-like star in the constellation Cancer, about 40 light-years from Earth. In cosmic terms, that is practically next door, and when scientists first measured its density and composition, the results were so unusual that they had to check their instruments. 55 Cancri A is roughly twice the diameter of Earth and about 8 times its mass. That makes it what astronomers call a super-Earth, a rocky planet bigger than ours, but smaller than a gas giant. But its composition is unlike anything in our solar system. Spectroscopic analysis suggests that up to a third of the planet's mass could be carbon, much of it in the form of diamond. Let that sink in for a moment, a world where diamond is not a precious rarity, but a basic building material. Where the geological equivalent of dirt and rock on Earth is crystallized carbon worth, by our economic standards, approximately $26 nonillion. That is a 26 followed by 30 zeros. The number is so large it has no practical meaning. It exceeds the total value of everything humanity has ever produced by a factor that itself defies comprehension. But the diamond is not even the most interesting thing about this planet. And what scientists discovered about its surface conditions is something that belongs more in a fever dream than a research paper. 55 Cancri e orbits its star at a distance of just 2.2 million kilometers. For comparison, Mercury, the closest planet to our Sun, orbits at about 58 million kilometers. This planet is more than 25 times closer to its star than Mercury is to ours. A year on 55 Cancri A lasts just 18 hours. Not 18 days, 18 hours. You could celebrate your birthday, and before the next one arrived, you would not even have finished a day on Earth. At that distance, the surface temperature on the day side reaches approximately 2,400 degrees Celsius. That is hot enough to melt steel, titanium, and most metals. The planet is tidally locked, meaning one side permanently faces the star while the other faces away into the cold of space. The day side is a hellscape of molten rock and superheated carbon. The night side is cooler, but still hundreds of degrees beyond what any living thing could endure. Recent observations from the James Webb Space Telescope have added another layer of mystery. Webb detected evidence of a substantial atmosphere on 55 Cancri e, something that should not exist on a planet this close to its star. Solar winds should have stripped any atmosphere away billions of years ago. The fact that an atmosphere persists suggests volcanic activity so intense and so continuous that it is constantly replenishing what the star strips away. The planet may be covered in volcanoes erupting not lava as we know it, but molten carbon compounds, constantly resurfacing the world in fresh layers of exotic minerals. But here is where the story takes a turn that most people never hear about. 55 Cancri e is extraordinary, but it is not unique. The universe is filled with planets that make our solar system look almost boring by comparison. And the deeper we look, the stranger they get. Take HD 189733b, a gas giant about 63 light-years from Earth. From a distance, it looks beautiful, a deep azure blue, like a sapphire floating in space. You might think it has oceans. It does not. The blue color comes from its atmosphere, which is loaded with silicate particles. When it rains on HD 189733b, it rains glass. Molten silicate glass, driven sideways by winds that blow at over 7,000 kilometers per hour. That is roughly 9 times the speed of sound on Earth. Imagine standing in a hurricane where the wind is carrying shards of molten glass at Mach 9. That is a Tuesday on HD 189733b. Then there is WASP 76b, where astronomers have confirmed that it rains iron. The day side of this planet reaches temperatures of 2,400 degrees Celsius, hot enough to vaporize iron. Iron atoms rise into the upper atmosphere on the day side. get carried by atmospheric circulation to the cooler night side, and there they condense and fall as liquid iron rain, droplets of molten metal falling from alien skies. This was confirmed through high-resolution spectroscopy in 2020. It is not a hypothesis, it is an observation. There is a planet called TARES 2b that reflects less than 1% of the light that hits it. It is the darkest known planet in the universe, blacker than coal, blacker than any paint or material we have ever created on Earth. Scientists are not entirely sure why. The leading theory involves light-absorbing chemicals like gaseous sodium and titanium oxide in its atmosphere, but nothing fully explains how a planet this size can be this dark. It is a world that seems to swallow light itself. And then there is Gliese 436b, a planet made largely of water, but water that behaves in a way that violates every intuition you have. The planet's surface temperature is about 440 degrees Celsius. Water should be steam at that temperature, and it is on the outer layers. But the gravitational pressure is so intense that deeper into the planet, the water is compressed into a form called Ice 7, a type of ice that exists only under extreme pressure, solid and dense even at temperatures that would boil a kettle in seconds. This planet is simultaneously burning hot and made of ice. Physics allows it. Your brain may not. So what does all of this tell us? Why should you care about diamond planets and glass rain and iron storms on worlds you will never visit? Because these discoveries are rewriting our understanding of what planets can be. For decades, our models of planetary formation were based almost entirely on our own solar system. Rocky planets close to the star, gas giants further out, everything made from roughly the same ingredients in roughly the same proportions. Our solar system was the template, and we assumed the universe followed the pattern. It does not even close. The universe creates planets from whatever materials are available under whatever conditions happen to exist. Around carbon-rich stars, you get carbon planets, worlds of graphite and diamond instead of silicon and iron. Around metal-rich stars, you get dense metallic worlds. Around binary star systems, you get planets with two sunsets, orbits that would seem impossible under simple gravitational models. Every new exoplanet discovery is a data point that challenges our assumptions. And we have now confirmed over 5,000 exoplanets, with tens of thousands of candidates waiting for verification. The Kepler mission alone found that there are more planets than stars in our galaxy. The Milky Way contains an estimated 100 billion to 400 billion stars. And on average, each one has at least one planet. The numbers are staggering. Among those hundreds of billions of worlds, the variety is almost limitless. We have found planets orbiting pulsars, the spinning remnants of dead stars bathed in intense radiation. We have found planets in the habitable zone of their stars, where liquid water could theoretically exist. We have found planets so close to their stars that they are being actively torn apart, leaving tails of debris like comets. And somewhere in that immense catalogue of worlds, there may be planets we have not even imagined yet. Planets with chemistry so alien that our current models cannot predict them. Planets with conditions that enable forms of complexity we would not recognize as life, but that are, in their own context, just as remarkable as anything on Earth. The diamond planet is spectacular. It captures the imagination because we assign enormous value to diamonds on Earth. But the deeper lesson is this: the universe does not share our values. It does not know what a diamond is worth. It simply creates endlessly, under every possible condition, in every possible configuration. Diamond worlds and glass storms and iron rain are not anomalies. They are the universe doing what it always does, taking the available ingredients and assembling them into something extraordinary. And if the universe can create a planet made of diamonds without any intention, without any plan, without any awareness of what it has made, then the question is not whether the cosmos is creative. The question is whether creativity is a fundamental property of matter itself. Whether the tendency to form complex, beautiful, improbable structures is not something life invented, but something the universe has been doing since the first atoms cooled from the plasma of the Big Bang. Every diamond on that distant world was forged by pressure and heat. The same forces that forge stars, that forge character, that forge everything worth having. And every one of those diamonds is hidden in the dark, 40 light years from anyone who could appreciate them. The universe does not create beauty for an audience. It creates beauty because that is what matter does when you give it enough time and enough energy. And that might be the most astonishing discovery of all.